Okay, so basically, when we're talking about chemistry, we need a little background before we get into talking about energy, because we need to know that there's molecules that make energy, okay? And that's what we're going to learn tomorrow. But so I just want to learn a little bit about atoms, elements, compounds, molecules, and stuff like that. Basically, rule number one, everything is made of atoms, except energy. Energy is made of waves. Energy is like something different. Like, basically, when we talk about atoms and molecules, we're talking about matter, right? Everything. So when I say everything, you could write in parentheses up here maybe matter, because matter is everything that takes up space or weighs anything, right? And energy is the only exception to that. Like, if you have a flashlight, the flashlight weighs something and it takes up space, but the light that comes out of the flashlight doesn't take up any space and it doesn't weigh anything. And so that's energy. So basically what we're talking about is matter. And as far as, by the way, how far down do I go here? So, all right, all the way.
Right there.
Okay, all right. So as far as this goes, we have basically two kinds of matter. And those two kinds of matter are, I'm going to make like a little tree here. Pure substances and mixtures. Right, and I'll tell you right now, just to get down to what pure substances are, you have to understand what a pure substance is to understand mixtures. A pure substance is when you have the whole thing, I did this last time, made of the same type, whoops, particle.
So like wood isn't a mixture though.
Well, actually, believe it or not, wood has parts of it that are pure.
Wood is a mixture.
Wood is a mixture, right? Yeah, wood is a mixture. Right. There's the cellulose, and then there's some other stuff. But I'll give some other examples. Did you have your hand up, David?
Yeah, I was say what a mixture is.
You were gonna say what a mixture is? Hold on. Let me say one more thing about this. There's two kinds of pure substances, and I'm going to talk about that so you guys are clear what I mean. And that's basically elements and compounds. And we'll let Damon tell us what a mixture is in a second, but I want to make sure that we have this first. And now what I'm going to do, you guys continue your notes under here. I'm going to start back up. I've got this limited amount of space I can use for the video camera. And so I'm going to, has everybody got this part?
Yeah.
I want to move back up. So I'm going to go back up here, and I'm going to write elements and compounds up here so I can define them. You can just continue underneath what you started writing. Does that make sense? So you guys just keep writing down under here. Hopefully we can see this on the camera. That says elements. That says compounds. Now, an element Element is a collection of all the same type of atom. So make sure you write that down. You guys are doing a great job. Tough way to start Monday, but you guys are doing good. All the same kind of atom, meaning that when you guys have maybe if you've had atoms, it's fine. If you haven't, we're not going that deep into it, but basically an atom is the smallest piece, P-E-I-C-E, sorry, smallest piece, no, it is P-I-E, isn't it?
Yep.
Dang it. P-I-E-C-E of matter that still has its own properties. So, like, think of a piece of gold. By the way, over here on the wall is the periodic table of the elements. You might have seen this before. This is a table that has every single element that exists. Everything that something is made of in the universe is on this table, as far as we can tell. From the smallest atom, which is hydrogen, they get bigger as you go along. Here's helium, number 2, and all the way across they keep getting bigger and bigger. There's lead, number 82, and radon, and uranium, number 92, and all the way up to number 114. They're all different. So when we say an element, like right here,
Why are there empty spots?
some of them haven't been discovered yet.
How do they know they're there?
There's some rules that all of them follow, and there's a couple of empty spaces that haven't been observed, but we know they would have to exist.
Yeah.
But that's a story for chemistry class when you take that. Let's look at gold. Gold is Au because that's its Latin name, aurum. But the point is, all gold atoms are alike. On one side of gold is platinum, on the other side is mercury. And mercury atoms are different from gold atoms. Platinum atoms are different from gold atoms. They're all, but if I have a collection of the element gold, it's all the same kind of atom. That's all you got to know. I have here, it's kind of cool, I have a little collection of elements. I'll show it to you guys.
With elements?
I have elements. I have a bunch of them. I have my little
Are they pure?
element briefcase, and they're pure, yeah. And these are all things on the periodic table. Here's manganese, which is number 25. Here's calcium, which is number 20. This here, here's I don't know what the highest number is. I see 83 right here, bismuth. This is arsenic, which is, where the heck is arsenic? There's arsenic right there. Scary stuff. Arsenic is bad stuff. This is bromine, number 35. So the point is, I'm going to pass these around. These are pure forms of elements.
So eat it all.
So you know, everything in here, each vial is filled with basically all the same kind of atom. Here's sulfur, bright yellow.
Sulfur's weird.
And most of these, like here's antimony, that's a metal. But the point is, you can look through these. Now, please don't break them. Like, seriously, 10 years, nobody's broken these. I'm counting on you guys to do the same. If this one breaks, we leave the room right away. I should hang on to it, but I'm going to trust you guys with it. This is bromine water. If this breaks, this will become bromine gas, which isn't too different from chlorine gas. It won't kill us, but it'll make us cough for about 10 or 15 minutes. And so, if you hear glass break, get up and leave. If you make the glass break, you might as well leave too, because you're not coming back. Whoa!
Unless you break it.
Unless I break it, right?
Why is there one missing?
What's that? That used to have mercury in it. We're not allowed to have mercury in the school, so I took the mercury one out.
Why?
Because mercury is a neurotoxin that can poison your nervous system and give people cancer, kidney failure, all this other liver failure, a lot of bad things.
There's nothing in this, is there?
In what?
The source.
Phosphorus, yeah, that's like an orange powder at the bottom there. Yeah. Okay, so
Open these.
you don't open the glass ones. You don't open the glass ones. They're sealed in there.
Well, like, why do you have it?
Well, that's for you to. It's for you can see it. You just can't open it. Like I said, if you opened it, that would fill the room with a toxic gas. That if
Just
you
by
stick-
hitting the air.
Where do you get
What's that?
Just by hitting the air.
Yeah, just by hitting the air. It would just like chlorine gas. We used to use chlorine gas as a weapon in World War I, called mustard gas. It was pure chlorine gas, and it would spread across the land and it would choke people. Hi,
I got an escort Andrew Kemp downstairs.
really? I just got it back.
Yeah? Well, I guess a lot. All right, I'll come up at the end of the class.
Could you? This is
Yeah, no.
because I'm giving some notes. How about this? When I'm done with the notes, you can have them. Okay, I'll send them down.
Okay.
You're gonna go down
Thank
by
you.
yourself if I send you down?
Okay.
All right.
What is
Thank,
chromium?
thank you, sir.
Thank you.
Chromium is a metal. Chromium is one of the components that goes into steel. But, okay, so here's the thing. So those are all the elements. Basically, everything that we know is made of those substances. What did I just do? I did not just lose my laser pointer, right? Really? Seriously? Ah, I still got it. Okay. And so, but here's the thing. The other kind of matter is compounds. And compounds, there's three rules. This is another thing to write down. So even if you're looking at this, you got to write this down because I kept you here so you can take those notes. So why don't you make sure you get these compounds? Compound means to put together, right? Compound. So two or more atoms chemically combined, and I'm going to explain what each of these means, in a fixed ratio. Some tough words here. So write those things down, leave a little space in case you have to write an explanation, and then I'm going to give you a sense of what that means.
It just means like a fixed ratio, so it's the numbers are exact and another substance.
Right, yeah, exactly. Exactly, like H2O. So here's the thing. Okay, first of all, two or more atoms. Notice how most people, when I said, if I said two or more and left a blank here, most people would say elements, right? That's what pops into your mind. Well, a compound must be made of two or more elements. But it's not necessarily. I mean, usually it is, but I'll give you an example. Like O2, whoops.
What is in this?
Oh, hold on. O2 is oxygen gas. O2 is made by combining two atoms of oxygen. They're not different elements, they're different atoms. What is in what? What does it say? Oh, that's lithium. Lithium is a metal that's kept in mineral oil because if that was exposed to air, the moisture from the air can make it burst into flame.
Are you serious?
I'm serious. It's not as cool as all that. If you guys are good, I'll get a big piece of that and I'll throw it into some water and you'll see it. It'll pop into flame. It'll make this purple flame that's real cool.
In the air, like you put in water.
In the air, not so much, but if it got water on it, like my mom told me a story about a kid that when she was in high school, he stole a piece of that from the chemistry lab and he stuffed it in his pocket. And on the way home on the school bus, he started to sweat, and the water from his sweat caused it to burst into flame. And you know, say liar, liar, pants on fire. Well, it's sort of like that, except he was a robber.